Greetings everyone! Today I will review a no longer so cheap Chinese LED fixture from AliExpress. It is sold by Shehds in the price range of 50 to 60 euros. I bought one during a sale and paid 40 euros in total. They promise 180 watts of light output with RGBW, which if true is an impressive amount of power. Let's see how this fixture fares. I will use my updated equipment and methodology that I explained in detail in my review of the Shehds 7x18 watt metal fixture. This is a technical review from the point of an engineer, so be prepared for some graphs and tables. Let's get right in. First, let's think about where in the product stack this power sits. This power sits comfortably at the top of the classical Chinese LED powers. On the bottom is the 7x12 watt RGBW power, then as a step up comes the 18x12 watt plastic unit I reviewed last time, and then this unit, together with its slimmer sibling in the high end. From a product stack point of view, this fixture today presents itself as offering the same power as its flat sibling, with the drawback of being more chunky. Just from an advertising perspective, it should not be much brighter than the plastic unit. However, as we saw in my last review, the 18x12 watt RGBW plastic power has significantly lower power than advertised. So maybe this unit is brighter as well. The internals are as follows. First, there's a power supply board. This outputs roughly 23.4 volts and puts them into the dimmer board. The dimmer then takes this voltage and sends the power to the LEDs. While being at this, the dimmer also sends the 24 volts straight to the 120mm case fan. The LEDs themselves are mounted on a custom-made aluminum PCB with an attached heatsink. With only one side removed, the fixture looks like this. Heatsink and fan are marked with an arrow. The case is of surprising sturdiness, but simultaneously of bad quality. Let me elaborate. The two big elements that make out the casing are made of injection molded aluminium. In the back is a metal plate with the inputs and outputs. On the front are the lenses that are held together by two metal plates. As delivered, this is all quite confidence-inspiring, and you will most likely be able to just stand on it with no damage to the fixture. A plus is the power input and output via PowerCon connectors. There are cheaper offerings of fixtures in the same case from different companies, and they have fixed plug. The U-brackets are also great with a thickness of 2.5mm. However, if you start looking at the fixture in more depth, and if you dare to disassemble it, you will see the problems, like the 2 to 4mm gap at the back, as an example. Also, the two sides don't align, which does not come through on the video as bad. The screw holes don't align as well, and there are gaps everywhere. So this is definitely the most sturdy case, while also being of bad quality. However, I disassembled and reassembled it multiple times, and always it worked. And so these issues are mainly cosmetical. The unit uses a 120mm fan to cool the LEDs. The fan is unfortunately not temperature controlled and runs straight off the 24 volts of the power supply. This leaves us with a quite noisy but not too whiny fan. I have seen much worse, but it is definitely far from perfect. The cooling only consists of the large aluminum PCB, on which a heatsink is attached. It is being blown on by the case fan and thus stays relatively cool. The temperature is nothing to write home about in the stock configuration, and thus I did not test it. Generally speaking, this has some cooling capability and should be able to dissipate 180 watts of power. The Shehds power has CE certification, and they also put a shiny CE sticker just for good measure. So all good in that regard. Before going into the details of the measurements, I want to prepend a small subjective evaluation. The LEDs are quite bright. The dimming curve for red is not great, but we had much worse. and just from looking at it, I would expect a beam angle of 24-25 degrees. I proceeded to measure the brightness and the beam angle of the unit. I did that with the brightness sensor of a Samsung Galaxy S20 FE, so not the most accurate thing, but I think it should be fine for relative comparisons. This leads us to a maximum brightness of around 5000 lux, which is almost double that of the 18x12 watt RGBW plastic power. This fixture has a beam angle of 11 for 1/2 and 19 for 1/10 of the maximum brightness. As a quick information, the LEDs are 3 parallel sets of 6 LEDs in series. This needs to be kept in mind for the following current values and voltages to make sense. They are all given for the whole board. They advertise the power of the LED being 12 watt. That should be true, with my measurements telling me an LED power of 10 watt per LED. In total, this would add up to 180 watts, which is equal to what is advertised. Again, the obligatory disclaimer here. The maximum safe voltage of an LED is not a number set in stone. Every LED can have every possible power. The only question is how long it is able to sustain it, with overdriven LEDs lasting only minutes to milliseconds. In the ideal world, one would thus use a constant current driving method. This leads to manufacturers only giving out a forward voltage, the voltage where the LED starts to function, and then a fixed current rating. This unit, however, does not use a constant current driving method, but only applies a constant voltage. With a constant voltage, you need to use the voltage as the defining number for limiting or rather setting the power. And for my measurements, I just took voltage values as I deemed good. They are what I found to be the generally accepted voltages for driving LEDs. But again, this is not how LEDs are supposed to be driven. This means that all this, from the manufacturer's 12 watt all the way to my measurements, this is all highly flawed. I could use a CC method, but since I have no way of knowing the exact type of LED, I have no idea what the maximum current would be. Anyway, the actual max power is in the same ballpark than what is advertised. We can see the dimmer board on the right here. It is a pretty straightforward board. This chip is the brain of the fixture that sends out the PWM signal, and this signal then gets amplified by these MOSFETs. This is also the moment we realize that the LEDs are not driven with a constant current method since, there is no circuitry for that. With that out of the way, let's get to the measurements. I have explained my methodology in more detail in my review of the 7x18 watt RGBW Amber UV Shehds par, but here is the TLDR. The dimming works via PWM, which is the standard way of dimming LEDs. The voltage looks like the picture on the top. From that we can get the PWM duty cycle and the maximum voltage during on. The switching frequency is also measured here. For this dimmer board it is 15.5 kHz, which is quite fast, and definitely done in a way that there is no visible flickering even for cameras. Additionally, I measured the on current the LEDs get during the pulse. This was made a bit tricky because, as you may be able to perceive, there often are current spikes at the start or at the end of every pulse. These are the most important data points I got with this method. The peak voltage is minimally different but generally identical for every LED. For red it is a bit lower than for the other colors, which is likely due to the high current. The maximum duty cycle differs quite much. For red it is 15.8%, for all the other colors it is 33.5%. On the right of the table there is the current during the pulse, the corresponding power per color, power per LED per color, and then on the right the total power as supplied by the dimmer board and the total power per LED. The total LED power is 105.4 watts and the total power per LED 5.86 watt. This is lower than the advertised 180 watt. The red LEDs are being overdriven quite a bit with 1.5 watt per LED and my safe measurement saying 0.63 watt. This is likely not going to kill the LEDs in a short amount of time, but it's definitely not perfect. Finally, a quick word on the strobe behavior. I'm only testing the strobe with the menu on the par itself, not with DMX. Here we can set a strobe value between 1 and 99, and according to the number, the pause time between the pulses decreases. The light pulse stays at rock solid 30.9 milliseconds, and you can see the pause time in the table. Of course, the strobe is overlaid with the standard PWM signal. I did not notice strobe jitter when fading, and just as a fun fact, they advertised strobing between 0 and 10 Hz, and that is not what I measured, with the maximum frequency being 15 Hz. But I won't complain about over-delivering, of course. I did test the DMX control, and the 4 and the 8-channel mode both work. The manual from the package provides the DMX description what which channel does. There is a sound to light function. It consists mainly of a dark fixture that gives a flash when the loudness reaches a threshold. You have several modes for that, which only differ in the color of the flash, which can be RGBW or secondary colors. And then there is one mode where it actually cycles through the colors based on the beat. With this low amount of sound to light functions and no way of modifying the sound sensitivity with a dial, the sound to light mode is pretty useless, so just don't bother. Thanks to the person from Reddit who gave me the idea. I tested if this fixture has a secret menu. To my surprise, it does, and it shows much about the inner workings of the fixture. You get there by pressing the menu button for 3 seconds. However, don't do that just now. First, hear me out. In the secret menu, you can set the maximum brightness the power reaches when setting the DMX value to 255. Effectively, this is an upper limit of sorts. Secret value number of 255 means that at a DMX value of 255, the duty cycle of the according color is 100%. When it is not 255, the fixture takes the secret menu number, for the sake of argument being a 16, and distributes it over the 255 DMX values you want to give to the par via DMX. This would mean that the LEDs are off for the DMX values of 0 to 15, on the lowest duty cycle for 16 to 31, and so on. From the factory, the values for the individual colors are shown in the table. You first realize that the values are quite small. This has several reasons. First, the power supply has a voltage that is too high for the red LEDs, and so they have to be protected from the high voltage by limiting the exposure time. Secondly, the manufacturer limits the power for all LEDs, regardless of the color, relatively harshly to not run into the power supply over current protection. This hard limiting comes at the cost of resolution when fading. You can clearly see the jumps in brightness every time the DMX value reaches a new threshold. This menu gives you the option to do quite interesting things with the LED par. It shows many things, the most important being that we now know where the bad dimming curve for the red LEDs come from. But it also means that this is not set in stone. Later, there will be a section about possible modifications and an evaluation based on that. As a small side note, I listed all the values you can change in the secret menu. Then, let's proceed to the detailed look at the power supply. A sticker on the side tells us this unit is called HC-P100W24V and outputs 24 volts at 4.1 amps. On the board is a writing which could be interpreted in a way that the unit has 115 watts. We will see which of those two numbers is correct. The unit has a short circuit protection in the sense that it switches off when a short circuit occurs, and it has an overcurrent protection that kicks in at 150 watts. There is no hot and cold side separation by a gap in the PCB. The power supply is not compatible with 90 to 240 volts AC from my testing. I have a beefy variable AC transformer. I live in Germany, which is a 240 volt, 50 Hertz country, and I gradually lowered the input voltage. At all colors, full on, it starts giving off a strange sound when reaching 120 volts AC. And below that, those sounds get worse. So not compatible according to my testing. Maybe they apply different settings for 120 volt countries, or the 60 hertz help at those voltages. I honestly don't know. There is a potentiometer on the output side with which you can set the output voltage between 20 and 29 volts. The input may be fused, but I don't know with what amperage. The idle power of the power supply is 2 watt and the full-on power drawn from the wall is 134 watt. All this seems quite acceptable for a cheap no-name power supply, and I have a bit of trust in this power supply. But it is definitely not a perfect one. Again, I am no electrical engineer, and thus I cannot actually evaluate whether or not this is safe. We realize that the maximum power of the power supply means that this power supply is not capable of driving the LEDs at their max rated power. The only real measurement that I can do is an efficiency measurement. I measured the power drawn from the wall at different power levels. Importantly, my mains power meter is not precise at low power levels, but for example at 70 watt, this is negligible in my opinion. In the end, the efficiency stays rock solid at 71%. So all in all, this power supply is not total rubbish from my limited knowledge. The main problems of the power are, in my opinion, the following. First, the semi-good casing. Secondly, the loud fan. Thirdly, the bad dimmer curve for red. And fourthly, the lower power than advertised. We can't really do anything about the first problem. After all, the case is a quite solid piece, and throwing it away would also be a shame. So not really feasible. The loud fan is fixable with a PWM temperature controller, a DC-DC step-down converter, and a new PWM fan. This should reduce the noise significantly, but will set you back around €12. Less if you buy in bulk. The bad dimming curve, in particular for red, is to some extent solvable without any expense. As stated previously, there is a potentiometer on the power supply with which we can set the output voltage in a small range. We can just turn the potentiometer to get around 21 volt, and then we can increase the secret menu number to reach the desired power. This will decrease the choppiness of the dimmer curve a bit, but it won't solve the problem completely. For that, we would need a significantly lower voltage power supply or a better driver board, and while this is theoretically both possible to get, the economics will never be in favor of this. Just look at the price of an 18 volt power supply in comparison to a 24 volt one, and you look at a many dollar difference. So there is the possibility to enhance the dimming curve, but not to solve the problem completely. And lastly, the power is lower than advertised. You can increase the base power by just setting the secret menu number higher. However, you will only get so far with this power supply. And I would advise against it when you don't have a way of then measuring the power to know if you are in a safe range. You could buy a new 200 watt, 8 amp, 24 volt power supply board. I think the economics are not in favor for that. However, it is definitely possible. But please, make sure not to buy these strip-styled LED power supplies, even if they are absolutely dirt cheap. I tested 2 different modules and they did not deliver what they promised. And I have credible sources that almost all of them don't deliver. Don't use them. They are bad. I would just use the potentiometer to decrease the voltage and the secret menu number to increase the power level a tiny bit so that the maximum power of the power supply is being reached. And then be happy with it. If the €12 for a silent fan during standby are worth it for you, I don't know. For me, it was a no-brainer. If one of the LEDs fail, 33.3 of the LEDs fail, but the rest works normally. I had one white LED fail and thus needed to get a replacement board. or at least a replacement. They sent me replacement LEDs free of charge, which is confidence inspiring. I was able to desolder the old one and resolder the new one. But I don't know if they also would have sent me the full LED assembly board. Since the whole unit is fully screw-based and does not use glue, it is quite easy to disassemble it with only a minor problem laying in the misaligning screw holes. Also, there is a great amount of space in the unit, which makes repairs easy. And with that, we get to the wrap-up and the price evaluation. The power works, which is always nice, and in terms of the product stack, it is definitely a lot brighter than the Tier 1 and Tier 2 products. I also can't see any immediate fire and health hazard. The power supply is solidly built and has a mini advantage in that the cables were neatly managed in the case. Additionally, the LEDs are as advertised, with having 10 watts each, and that the unit has a CE certification is also good. That the unit has an actual heatsink and thus good cooling capability is also greatly appreciated. On the flip side, it has this constant noise level and a bad dimming curve, in particular for red, and a lower power than advertised. You will get all this for 50 to 60 euro. Let's compare this fixture to other options a person might stumble upon when looking for a fixture online. First, I will compare it to the other standard Chinese products and different Chinese options that are not standard in my definition. The Shehds 18 x 12 watt RGBW par fits neatly between the tiers of Chinese LED pars. We already know that the Tier 2 plastic 18 x 12 watt par has not the advertised power, and this is definitely an upgrade. This is the first metal-cased LED par in the standard product stack, and it is definitely way better than anything we got so far in the standard tier list. I would expect this unit being again worse than the Tier 3 flat case unit when it comes to the case, but equal when it comes to the light power. This is the first serious fixture for front washing small venues. I would choose this 18 x 12 watt RGBW unit every day over the small 7 x 12 watt or the medium 18 x 12 watt unit. However, I would likely buy the RGBW Amber UV version. For front washing, UV and Amber are always nice, and even if you don't need the colors, the RGBW Amber UV version will likely have a better power supply. With deactivating, for example, the amber color or the UV color, you possibly would be able to push the rest of the colors to 180 watts. But I don't know that since I don't own these fixtures. From a price to performance point of view, this 18 x 12 watt RGBW Shehds fixture is definitely in the sweet spot for Chinese fixtures. The 7 x 18 watt RGBW Amber UV are also great value, but they both have their individual application. And now a comparison to quality China imports. The German stage product seller Thomann sells a fixture called Stairwell CX30 RGBW for 140 euros. I have 4 of the CX3, which are the identical predecessors, just with a fixed plug. They are better. The case is not made to be stood on, but of high quality, and there is an actual sophisticated dimmer in there, which takes into account the needs for the red LEDs, and it is brighter. But admittedly, it is also more than double the price. Cameo sold a unit in the same looking case, just without the bad quality. I once used this fixture, but since it is no longer in production, here we take the new version as a comparison unit. It costs almost 400 euros. This is in every way better, but when it comes to pure light output, I can't recall it being brighter than our Shehds unit. Personally, I could see myself buying this power. It is not that dangerous and has quite a bit of punch. However, when I look at the Stairwell, I would probably buy this and pay a bit more to get the peace of mind that 1/3 of the white LEDs won't just randomly die. If I was in a professional environment like TV or big stage production, and I wouldn't have the money for moving heads or washes, I would likely buy the Cameo unit. But as a random guy, this is likely too expensive, and going with a quality China import is almost always better. But if you are seriously money constrained, going with the Shehds unit will make sense. Just know what you're getting into. The neat thing is, I don't need to tell you what to do and what not to do. You have all the information on hand, and you can decide what is the best for you. May your path be illuminated by a bright but not burning Chinese LED power. And goodbye.